Assalamualaikum and good day everyone. So as for today, we are going to begin with the next chapter, for the civil engineering material subject, which is the steel, right? So this is another type of material, that we can also use in the civil engineering construction. So this is another material that is other than concrete. So we will begin with the learning outcomes. So at the end of this lesson, you should be able to explain the basic science and engineering fundamentals pertaining to the type of steel, properties of steel, manufacturing process of steel, steel products, disadvantages and also advantages of steel, and also the protection of steel. Right, so this is another material, with the material properties, that is totally different from concrete. So for the introduction, steel is used in a variety of types and forms in every building. It is also the strongest, the most resistant to aging, and generally the most reliable in quality. So steel is completely industrialized material, and it is subjected to its tight control of its content and the details of its forming and also fabrication. Right, so we know that as for steel, it is a prefabricated material, which is manufactured in the factory, right? So other than it is different from concrete, whereas we can either use it as a precast concrete, whereas we can construct the elements, in the factory, or it can also be cast in situ, right? So it means that it is mixed in the plant, then we are bringing the concrete to the site, then only we cast the concrete material. But as for this, as for steel, it is usually custom made, in the factory, right? So that is why, we say that it is most reliable in quality. Because when it is manufactured in the factory, right, so it is under stringent control. So therefore the quality, of this material will be better. It has additional desirable qualities of non-combustible, non-rotting, and it is dimensionally stable, with time and also moisture change, right? So we have a variety of types of steel. So the main properties of steel, that we have to know, is that it is strong under compression and also tension, right? So this is quite different as for concrete, because as for concrete, it is strong in compression, however, it is very weak in tension. So we know that as for concrete, it cannot be pulled out, right? So we cannot just simply pull out or bend concrete, or else it will break. In comparison to steel, it can be compressed, or it can also be pulled out under tension, right? So in comparison to concrete and also timber, this steel material, is a better material with a better property. So it can also resist excessive load, due to wind, earthquake, vibration, and also impact transfer load. So the factors in selecting specific application of steel. So we have to look into the strength level required, the mechanical properties required strength together with strength, the steel making, heat treatment, and other plant available, right? So we have to know on the manufacturing process as well, and also the arbitrary local conditions and also the code of practice, right? So we are going to learn also, on the types of steel, that we can use for the civil engineering applications. So these are the references, that we can use in order to use the steel material, which are BS 5950 and also BS 4360, which is for the structural use of steelwork in building. So structural steel can be divided into three categories, right? Whereas we can use the steel, in a variety of types of structures. So we have the first one is a frame structure, right? So when we talk about frame structure, usually we are going to have these steels connected together, right? So it consists of skeletal framework which carries all the loads, right? So you can see here, these are the examples. So one is a girder, right? So this girder actually functions almost the same as beams. Okay, right? So you can see that we have this horizontal oriented structure, right, or element. Okay, and also you can see this dome, right? So when we have this dome, therefore we have the steel structures, okay, the steel material that is connected together, okay, to form this circular shape structure. Okay, and also we have trusses. Okay, so usually on roofs, okay, we are going to have these trusses. So the function of these trusses is actually as the support to our roof, right? Okay, so that is why you can see that this steel reinforcements, this steel material, okay, are connected together, right? So it is connected together to form the support, okay, for the roof. Okay, so the steel members are used to carry lateral loads when acting as beams and girders, and also axial loads when acting as struts and ties. The steel frame are made of load-bearing elements, okay, which are tension members, columns, beams under combined bending, girder, trusses, and also axial load. Right? So for example, we have beam, okay, we have girder, we have dome, okay, and also we have trusses. Right? So when we talk about frame structures, okay, so it can be either one of these examples. Okay, then we move on to the next category, okay, which is a shell type structure, right? So when we talk about shell type structure, okay, it means that we are talking about structures that is quite thin, right? So for example, okay, when we are dealing with a water tank, right? So this carries axial stress load, okay, and the shell serves as a use function, okay, in addition to participation in carrying loads. Okay, so the main stress intention is the containment vessel, right? So this containment vessel, okay, is this tank, right? Okay, so for example, okay, this containment vessel is used to store liquid, water, okay, and also as a storage bin, right? Okay, so we can see here, okay, that this is considered as the containment vessel, right? So we have a structure, okay, that has to contain the liquid inside, right? Okay, so therefore, usually as for this type of structure, okay, it is thin, right? Okay, however, it has to sustain the loading, okay, so that this liquid will not seep out, right? Okay, so we have a variety of types of materials, okay, to be used in order to construct this water tank, right? Okay, so as for steel, okay, sometimes we are using the aluminium, okay, for the purpose of having this water tank, right? So if we are dealing with a structure such as water tank, okay, we have to ensure that the steel material that we are using, okay, will not corrode through time, right? Okay, so we have to ensure that the water is safe for use. Okay. Right, so the next one is suspension type structure, right? Okay, whereas we have axial tension to support system. Okay, so the major supporting element is the tension cable, right? So for example, when we have a suspension bridge, okay, so even the Penang Bridge, okay, is also considered as a suspension bridge, okay, in the middle of the bridge, okay, whereas you can see that we have the suspension cable, right? Okay, and also we have the pylon, okay, and usually if we have the suspension cable, right? Okay, so therefore the pylon will be quite far apart, right? So as you can see here, right? So we have this pylon, okay, so this is the location of the first one, and this is the location of the second one, and the rest of the span, okay, for the bridge will be supported by this suspension cable, right? And this suspension cable, okay, is made out of steel, right? So since the tension element is the most efficient way of carrying load, structures utilizes this concept, okay, are coming into increasing use, right? Okay, so usually we are usually using the suspension type of structure, okay, for bridges as well as for roof structures, okay, right? So there are a few um, types of structures also, okay, that is using this suspension system, okay. Right, so as for the type of steel, okay, there is an almost infinite numbers of kinds of steel available, since it is possible to make steel to perform under most known conditions. Okay, so this usage of steel, okay, will depend on the steel strength. Okay, so and it is to resist impact, to resist corrosion, Okay, so this is actually depending on the type of steel that we are using. Okay, then steel to take and hold a sharp edge. Okay, and steel to cut another steel. Right, so for the purpose of usually for mechanical purposes, right? Okay, so usually we are going to use this steel to cut another steel, right? So to do this, okay, we have to know the type of steel that we are using. Okay, so basically steel is composed of 98% of iron, okay, with the main alloying elements of carbon, silicon, and also manganese. Right, so similarly to concrete, okay, so we with the application, okay, we need to know what is the purpose of having to use this steel material. Okay, so therefore we will get to know, okay, what is the type of steel that we will be using. Right, okay, so as for steel, we can actually custom make, okay, the type of steel that we require. Okay, whether it is strong enough, okay, whether it does not it corrodes or not, right? So we can actually decide on that. Okay, the design of steel structures is based primarily on the yield stress or proof stress of the steel, but ductility, toughness, at normal and weldability are often important properties as well. Okay, so as for the yield strength or yield point of a material, it is defined in engineering and material science as the stress at which the material begins to plastically deform. Right, so to understand this, okay, when we talk about the strength of steel, okay, we are actually referring to the stress strain graph of a ductile material, okay, or the steel. Right, so as you can see here, okay, for any material, okay, it will undergo the elastic region first. Okay, whereas, okay, when we talk about the elastic behavior, it means that when we pull out our material, then we release our material, then it will go back to its original shape, okay, or its original length. Right, so for example, if we are referring to a rubber band, okay, for example, so a rubber band, okay, if you take a rubber band, then you pull it out, okay, then you release the pulling force. Right, so when you release, what happens to the rubber band is that it will be regaining its own length, okay, or its own shape, okay, its original shape. Right, so that is where, okay, we refer that as an elastic region. Okay, so similarly as for steel, okay, so it can be pulled out, and when the force is released, okay, then it will go into its original length back. Okay, so that is for the elastic region. Okay, so when we talk about yield strength, it is a point, okay, whereas it exceeds this elastic region, okay, whereas it will start to yield. Okay, when we mention that it will start to yield, okay, is that it will no longer go back to its original length. Right, so for example, if we pull out a steel bar, okay, so at certain point, okay, when we pull it out, it tends to be lengthened. Right, so it will go longer. Then when we release the pulling force, okay, or the pull out force, it will not go back to its original length back, okay, but it has elongate. Right, so it is much longer in comparison to the original length. Okay, so that is the point, okay, where we consider that as a yield stress. Right, so that is the point, okay, which is this one. Okay, this is the point where we are going to take this as the yield strength. Right, so as you can see here, okay, when it exceeds the yield strength, the yield limit, okay, or the yield strength, okay, then it will continue to yield, and it will continue to be under plastic behavior, okay, whereas our material, okay, or our steel will continue to elongate until it undergoes fracture, okay, fracture or failure of the material. Right, so that is the a ductile type of material, okay, whereas it will undergo this plastic behavior first before failing. Right, so this is different from concrete, okay, whereas the failure will be much more earlier, okay, in comparison to steel. Right, so prior to the yield point, okay, the material will deform elastically and will return to its original shape. Right, so this is the elastic behavior or the elastic region. Okay, then we have the plastic region.